AI agent action logs can show what happened but still miss the reason. This episode gives you a screenshot-ready agent intent, action, result audit chain for checking intent, approval, action, result, and human takeover. In May 2026, OpenAI described its internal Codex deployment. Traditional logs show a process start, file change, or connection attempt. Agent-aware telemetry can add user requests, tool approvals, execution results, MCP usage, and network policy events, reconnecting an action to its task context. This is one internal Codex deployment, not a guarantee that every agent becomes safe when more data is collected. The audit chain in this episode is a source-backed synthesis, not an official OpenAI template. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. First, unpack the phrase, "the action was logged," so you can see why a detailed event record may still fail to explain why an agent acted. Traditional logs are strong at recording events: a process started, a file changed, or a network request was attempted. Those events establish that something happened and help locate the time, object, and execution environment. But a command does not reveal which user request it served. A changed file does not reveal which acceptance criterion the agent was trying to satisfy. The same action might be a normal task step, a benign mistake caused by a misunderstood constraint, or behavior that truly warrants escalation. When the record preserves only the action, without the original request, approval decision, and result, reviewers must reconstruct intent by guessing. The human's first job is not to ask for a longer explanation. It is to define the audit questions: who set the goal, what was allowed, what ran, and whether the result matched the goal. Chapter recap. First, action logs prove that events occurred. Second, an event does not automatically establish user intent. Third, define the audit question before the log fields. Next, connect user intent and tool approval before the action so you can tell whether an operation served an authorized task or crossed its boundary. The first link records the user request, the goal, allowed scope, explicit prohibitions, and acceptance criteria. The second link records the tool and parameters the agent planned to use, making its proposed route visible before execution. The third link records the approval decision: automatically allowed, approved by a person, rejected, or stopped for leaving the sandbox. OpenAI's agent-aware telemetry can include user prompts, tool approval decisions, and tool execution results, placing operations back inside task context. An approval cannot mean only yes. It must identify the specific action, surrounding context, and authorized scope, or a one-time decision may become an accidental permanent pass. Routine low-risk work can follow managed rules. Out-of-scope writes, unfamiliar network destinations, and high-consequence changes stop so a person can review the plan and context. Chapter recap. First, preserve the user goal and boundary. Second, bind approval to a specific tool action. Third, people take over high-risk or out-of-bound actions. Then connect execution results, MCP usage, and network policy events after the action so you can distinguish completion, policy enforcement, and apparent success. Starting a tool call does not mean it succeeded. A zero exit status does not prove that the final artifact meets the user's requirement. The result link record status, relevant output, created or changed objects, and evidence against the acceptance criteria. When the agent uses an external service through MCP, record which service and capability it used and how the result returned to this task. Network access also needs policy context. Was the destination already allowed, sent for approval, or explicitly denied? A blocked request may show that a control worked. If the record says only request failed, reviewers may misdiagnose a safety boundary as a reliability defect. An allowed request does not prove that the answer is trustworthy. A person still checks whether the returned evidence supports the conclusion and whether the operation stayed in scope. Chapter recap. First, a started action is not an accepted result. Second, MCP usage returns to the task context. Third, interpret network outcomes with policy decisions. Now use the chain for human triage so you can separate expected behavior, a fixable mistake, and activity that needs escalation instead of blocking every alert. Start with the unusual endpoint or security event, locate its exact time and operation, then move backward to the user request, agent plan, and approval decision. Move forward through tool results, file changes, MCP returns, and network policy events to establish the actual consequence. If the action matches the goal, stays inside authorization, and passes acceptance, it is more likely expected behavior. If the goal is valid but the agent picked the wrong tool, misunderstood a constraint, or failed acceptance, it is more likely a benign mistake that needs repair. If the action diverges from the goal, crosses an explicit boundary, hides its destination, or causes a high-consequence change, stop automation and escalate to the responsible human. OpenAI describes its security triage agent surfacing analysis to a security team for review. Automation connects evidence. People make the final classification and response. Chapter recap. First, locate the chain from the unusual event. Second, classify behavior using goal, authorization, and result. Third, keep escalation and response under human judgment. Finally, complete the agent intent, action, result audit chain so you have a screenshot-ready card for an AI workflow. Box 1 records intent, the original request, goal, allowed scope, prohibited actions, and acceptance criteria. Box 2 records plan and approval, the proposed tool, critical parameters, reviewer, decision, and authorized scope. Box 3 records action, commands, file changes, MCP calls, and network destinations that actually occurred. Box 4 records policy, sandbox decision, network allow, prompt, or deny event, and the applicable rule version. Box 5 records result, tool status, relevant output, final artifact, acceptance evidence, and failure reason. Preserve only necessary sensitive prompt or credential fields, apply access and retention limits, and keep links to original evidence. Box 6 records the human conclusion, expected behavior, benign mistake, or escalation. Include the owner, response, and reusable rule. Publishing, payment, deletion, permissions, and security incidents still require human verification of original evidence. Screenshot this 6-box audit chain and use it when an AI agent acts unexpectedly. Chapter recap. First, connect every event with one task identifier. Second, bind the result to acceptance evidence. Third, keep sensitive and high-consequence decisions under human control. To sum up, AI agent action logs can show what happened but still miss the reason. Traditional logs show what happened. Connecting the request, approval, tool result, MCP usage, and network policy event makes the reason and consequence more explainable. AI can correlate events, flag gaps, and prepare triage. People define boundaries, approve risk, inspect original evidence, and make the final response decision. Which part is missing most often from your agent audit trail? Intent, approval, or result evidence? Tell me in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.